Assalamualaikum, Doctor. My name is Nurzatul Akmal. My metric number is SA21016. I will talk about problem number 1. The problem has given the molecule formula, the proton and NMR values, IR spectrum values, carbon 13 NMR values, and mass spectrum values. I will explain about proton and MR. Based on the slide, my group was separated the information given based on chemical shift, multiplicity, protons, and assignment. As you can see, it gives 5 different chemical shifts. Firstly, 7.26 until 6.36 ppm was shown multiplied in one peak with 1 H protons. Next, the chemical shift values show at 5.84 ppm as present as multiplied also with 1 H protons. This because transcoupling. Then the chemical shift values shows at 3.82 ppm as quartet in 2H protons. Next at 1.82 until 1.49 ppm it shows as doublet with 3H protons. Lastly at 1.11 ppm it shows triplets with also 3H protons. This is the structure that we predict. Uh, we can know why each of the protons can show different multiplicity by using n plus 1 rule. At chemical shift 7.26 until 6.36 ppm, it's stated multiplied because doublet of quartet due to doublet from trans hydrogen and quadret due to CH3. Next, we can know 5.84 ppm with multiplied because 4 plus 1 equal to 5, which means multiplied. Both of these chemical shifts shows that it was transcoupling. To know it was doublet, we can using n plus 1 rule at CH3 that was paired with 1H. It was stated at 1.82 ppm until 1.49 ppm because it was far away from another electronegative atom. At 3.82 ppm chemical shift, the CH2 molecule was paired with 3H protons and it has higher chemical shift because it was near with electronegative atoms. At 1.11 ppm, the CH3 was paired with 2H and it was clearly far from any electronegative atom.
So this is the IR spectrum. From the IR spectrum, we can get wavelength, characteristic, type of bond, and the functional group. For the first one, wavelength 3052, the characteristic is a medium, type of bond CsP2, C single bond H stretching, and the functional group alkene. For 2980, medium, sp3, C single bond H, stretching alkene. 2876, the characteristic was a medium, and the type of bond sp3, C single bond H, stretching alkene. It is same as a wavelength 2980. So for the next one, 1722, the characteristic was a strong C double bond O stretching. The functional group is a aliphatic ketone, and the 1652 medium C double bond C stretching alkene, and the last one 1184, the characteristic was a strong C single bond O stretching, and the functional group is a tertiary alcohol. After that, we can use 13C and MR to solve this problem. First, we can get information from 30C NMR is a chemical shift and the type of bond. So for the first one, 167.1 ppm, the type of bond is a C double bond O, which is carbonyl group. Second one, 144.3 CH double bond CH, which is alkene group. And 122.6 CH double bond CH, which is alkene group also. And then 60.9 sp3 carbon and 18.4 sp3 carbon, and the last one 14.5 ppm sp3 carbon.
A very good day I bid to everyone. My name is La Yun Han with the matrix number of SA21061. According to the mass spectrum information given, which is the MZ value, 114 represents the molecular ion peak, 99, 69 is the base peak, and 41. So this is how the fragmentation pattern of ion looks like. For example, the molecular ion with the MZ value of 114 are predicted like this. So how it goes to 99 is 140 minus 99 is 15. 15 might indicate the loss of CH3, which is methyl group, because the possible structure with the molecular weight of 15 is CH3. The same thing goes to the second fragmented ion predicted, which is 69. 140 minus 69, which is the loss of OCH2CH3 group. And the last cation structure predicted is with the MZ value of 41. It's because 114 minus 41 is 73, and this is the possible structure of fragmented cation looks like. DBE, which is the double bond equivalent, it is used to estimate the number of ring or double bond present in a particular structure. And the formula will be x plus 1 minus y over 2. The x stands for the number of carbon, while the y stands for the number of hydrogen. In this case, for C6H10O2, the double bond equivalent formula will be 6 plus 1 minus 10 over 2. So the DBE is equals to 2, which means that there is 2 double bond in the compound. By combining all the spectrum information given, this is how the predicted structure looks like.
Hi doctor, my name is Naraina Safa binti Narhariza. My number matrix SA21072. This is my turn, problem number 2. This slide is showing that FTIR spectrum. My problem have two spectrum, which is FTIR and NMR.
According this slide, it shows table analysis of FTIR spectrum. The table shows it has three highlight type of bone in the spectrum. To identify the type of bone, we can refer the IR spectrum table by frequency range. For example, at wavelength between 3000 until 2850, the type of bone that appeared was sp3. Next, at wavelength 1743, the type of bone was C double bond O stretching. Lastly, at wavelength range 1320 until 1000, the type of bone that shown was C single bond O.
Okay, now I would like to proceed with the NMR spectrum. From the NMR spectrum, we can actually tabulate the data into table form, which is chemical shift, multiplicity, integration, as well as assignment. So let's observe at the NMR spectrum. It is found that there are 3 signals. The 3 signals tells us that there are 3 different proton environments. So according to the first peak, which is at the most right hand side, which falls in the chemical shift of 1.12 ppm, it has a triplet peak, and integration of 3H. This tells us that it has the 3H represents of 3 proton on its own, and the triplet represents that there are 2 adjacent proton to it. So 3 proton on its own is CH3 coupled with 2 proton adjacent to it, which is usually CH2. So the assignment for it is CH3 coupled with CH2. For the second signal, which falls in the chemical shift of 2.3, it is a quartet and an integration of 2H. 2H tells us that it has 2 proton on its own, which is usually CH2, and the quartet arises due to 3 adjacent proton to it, which is usually CH3. So CH2 on its own coupled with CH3. So from the first and second peak or signal, we know that they are both attached to each other, they are neighbors. And for the last peak, which falls in the chemical shift of 3.7 ppm, it is a singlet and it has 3H. 3H represents that it is CH3, while singlet indicates that there are no adjacent proton to it, which means that this CH3 is isolated. It might be attached with other atoms such as oxygen.
We also use DBE technique to calculate the number of double bonds that present in the compound. Based on the slide, the formula of DBE is X plus 1 minus Y per 2. X is meaning of number of the carbon and Y is number of hydrogen in the compound. In this problem, we know that we have 4 carbon and 8 hydrogen. So by replace X and Y with the number of carbon and hydrogen, we can get it only has one double bond in the compound. Conclusion for this problem, the possible structure for compound with molecular formula of C4H8O2 is methylpropanoate.
Now for question 3, 3 spectrums are given, which is the FTIR spectrum and the mass spectrum as well as the mass spectrum. So from the 3 spectrum given, we are required to elucidate and predict the structure of the compound. So firstly, we can run the FTIR analysis. So from the FTIR spectrum, we are able to identify the functional group of the particular structure of a compound by knowing where a particular band lies on particular wavelength. So for instance, a broad band is observed at 3399 wavelength. It indicates the OH stretching, which also indicates the presence of alcohol. For the second band, which falls in between 3000 to 2850 wavelength, it indicates the CH stretching of alkane. And for the third band, which falls in 1040 wavelength, it indicates the CO stretch.
This slide was shown about mass spectrum. There's a lot of fragmentation peak present in this spectrum. The molecular ion peak is 74. By knowing its molecular structure, we also can know its other fragmentation peak, such as at 59. We know that we lost CH3 that with the molecule. Based on the mass spectrum, also we can get its base peak as intense peak. The base peak is 43 and it lost CH2OH.
So here is the NMR spectrum. So from the NMR spectrum, we can get a chemical shift, multiple integration, and assignment. So for the first one, 0.90 from the right side, from the outfield, So we can get multiplicity doublet, integration 6, assignment 2CH3 coupled with CH, and then 1.75 multiplicity non-net, integration 1H, and the assignment was CH coupled with 2CH3 and 1CH2. After that, 3.35 ppm doublet. The integration was 2H and the assignment was CH2 coupled with CH. And the last one is 3.92 multiplicity singlet, integration 1H, and the assignment was a H is isolated. So the second picture is a possibility of the structure. So you can see that the H is isolated. There is for 3.92 ppm equal to singlet. So and then CH2 for 3.35 ppm, 1 plus 1, uh, that is following for equation n plus 1. So it is a doublet CH non-net and 1.75 ppm CH3 doublet for 0.90 ppm. That's all from me.
And this is how the final structure predicted, which is 2-methyl 1-propanol. That is all from us. Thank you.